I think we first met. I think I first met you in 2007 at the IET or the IEE, as it probably was then, at ITSF, the International Telecom Sync Forum, as it was. It's now International Timing and Sync Forum, as more industries have started to use the same technologies. And I remember you did a keynote then about time, and you mentioned Ruth Belville in that, the Greenwich Time Lady. And it like really stood out for me, because obviously it's a technical conference, ITSF, about timing and sync, but it's lots of PowerPoints with bullet points and graphs and equations. There's even a few equations. And I remember yours stood out for me because it was just all photographs. And it was a really engaging way, I think, of getting that message across. But yeah.
I loved talking about, at the time I was writing Ruth Belville's biography, or maybe it had just come out. So I was still evangelizing about Ruth Belville's story.
Right.
And then what really struck me, and I learned a huge amount from that forum, as with all of the other technical meetings that I've ever attended. The story about Ruth Belville, which feels like this dotty old account from the past, this woman who would carry a pocket watch from the 18th century around London and charge people for a weekly peep at the watch. But I think the point that I was interested in making was that the time that she distributed with that pocket watch was accurate to 1/10 of a second from GMT. And it was with a certificate as well to prove that it was accurate to 1/10 of a second. And that was in the 19th century.
Yeah.
Which always just made me think that, like, the technology is one thing, but you've also got to understand what the needs were, what the kind of the user's point of view, and what did they value. And in her case, they valued a long-term trust that they'd built up with her. Yeah, I really enjoyed talking about her. Still do.
Yeah. Well, I don't know if you know, but it actually inspired a product. I don't know. I've just got one here, like Blue Peter style, that we prepared earlier. This was something that that Chronos produced, that we produced to do the same thing effectively. It's got a battery in it. It's got a GNSS receiver. It's got a small atomic clock in it. So the idea with that is you take it outside, synchronize it to GPS, disconnect it, and then you carry it inside, and it works as a piece of test equipment or something. So it was very similar, and it was inspired by, I think, Charles. I'm not sure, you must have met Charles in the past, Charles Curry. Yeah, he was inspired and sort of got the idea, I think, from the Ruth Belville story of carrying time. And the technology was just around this chip scale atomic clock, this tiny version of like a cesium oscillator would just sort of become commercially available for civilians. And so her story inspired, that actual physical product. So,
well, that's wonderful to hear. When did you bring that out?
I'm gonna have to admit my failing memory. You get to a certain age and you just can't remember things. It was after that. It was after 2007. I would say it was maybe 2010, somewhere around there. So we sort of sell that. We have another company that resells that into the power industry as a piece of test equipment. So you can use it to measure time signals, and it can also be a reference clock to measure time signals as well. So yeah, it was interesting. I know Charles got a name check in your latest book, which I'll do the product placement for here in the end. But I thought that was a really fascinating book, how time and clocks have controlled society, or people have wanted to use them, or even subconsciously now, we're all controlled by time and clocks. I think that's absolutely fascinating subject.
I'm interested in clocks. I'm interested in the technology of it, from the most ancient to the most modern. But I've always been interested in people, just as much, if not more. And when you look at the story of clocks and time, you're looking at the history of us. You're looking at the history of people, because of course, clocks are human-made devices. We make things for reasons. those, and it's nice to think that, all invention is just this kind of pure ideal to advance human knowledge. And in some cases that's true as well. But it's those other aspects of human civilizations that I find fascinating. It's about war and peace. It's about life and death. It's about money. It's about trade and, building relationships and controlling populations. And when I started to look at the history of clocks and history of timekeeping in general, you can't avoid looking at the history of the biggest themes in human civilization, which is what I wanted to kind of bring out in that book. And it just kind of makes me have respect, if not awe, for the people who make clocks all the more when you see just how important the devices that people like you make are in the history of humankind.
Yeah, absolutely. It's a fascinating thing. I put my wristwatch on today as well. I stopped wearing this after sort of lockdown. I don't know why it happened then, but spending all that time at home, and I got into the thing of just looking at time on my phone as everybody does, rather than. But this is a Casio G-Shock that's solar powered, and it's synchronized to the MSF time signal. So I have used it in the past just to look at clocks where you've got an LED display on some, it might be accurate to tens of nanoseconds, but you want to know that it's telling you when it ticks the seconds, it's telling you the right time. And I've actually used this to just check by eye that things are correct like that. But it's fascinating.
It's there's like a whole network of it's all about trust, really, isn't it? It's about knowing what timekeeper you trust in your life. And maybe we all stopped wearing wristwatches because in the lockdowns we were all, not all of us, many of us stuck in front of screens, and so you've got a clock in the corner of the screen. Your eyes never really needed to move down to your wrist. It was all looking at the screen on Teams or whatever. And we got back into the habit maybe after the lockdowns ended, that we got out and about more, and that we needed time that we trust. And so some people set a wristwatch wrong by 2 or 3 minutes because that helps them in their life. Either they're always late or they're always early or whatever. And some of us like to have the split second timing. I mean, I remember having a Younghans Mega 1, one of the first radio controlled wristwatches. It's actually got the DCF signal, which was easier to get even then in the southeast of England than MSF. And it had like this was, I guess, in the 1990s maybe, and it had a little numeral on the dial which showed you how many signals it had missed because it hadn't picked it up right. So how many days of DCF you'd missed, and it would go 1 and then 2 then 3, and it would count up to 9. And I used to get massively stressed if it got to like 3 and I'd missed the time signal for 3 days. I mean, it was still accurate to about 100th of a second. But it comes down to trust, doesn't it? Like we trust timekeepers that we know. That's why Ruth Belville was so successful, because people trusted her because they'd build up these long-term relationships. Yeah,
it's fascinating. I can't remember what age my kids were when they realized that we'd set the time in the kitchen on the clock. We'd set it like you say, 3 minutes fast to get them to school on time, saying, look, you're going to be late. But really there was an extra 3 minutes. But it's all fascinating stuff. I heard you on BBC Sounds recently talking about the pips as well. And that's something else that's been like a constant companion
for a century,
for most of our lives, isn't it? I remember being a teenager and listening to the top 40. Well, it was the top 20 when it started. When BBC Radio 1 used to be AM only, medium wave only, and they used to share the Radio 2 VHF frequencies on a Sunday evening, and you'd listen to the top 20, or later it was the top 40. I remember that it would always start with the pips, because they would mark the hour every hour, wouldn't they, on certain BBC stations?
I mean, it's the reason I was droning on about it was it's 100 years. I mean, this month it was 100 years to the day since the pips first started. So a century of a time signal which was accurate to think was about 1/5 of a second. So a century ago, you could get time in any home that had a radio set. to 1/5 of a second was pretty impressive.
Yeah.
And we've lived with it ever since, and it's become part of the soundtrack, not just in Britain. It is a British BBC technology, but anyone who listens on the world service over that century will have heard the pips just as much. And there's lots of pips around the world in other countries as well. And so it's become part of the rhythm of our lives. And we all, I think, have stories like yours about, you remember when you were a kid and this particular moment every week, the pips were the soundtrack. I think we've all had that. I mean, now, of course, the time signal landscape is much more complex, and we've all got access to time in many, many ways. But it's not all just about getting accurate time. It's about these social it's about kind of social synchronization of people coming together and knowing that people are hearing the same thing at the same time.
Yeah. It's very important. But there's another program as well, maybe a couple of years ago, where you were talking to a historian on the BBC about, I think that was about, or what one of the topics that you covered was, why are the 60 seconds in a minute? Why are the 60 minutes in an hour? And that sort of, question that people often ask, how do we define a second? And then why is this odd thing where there are 60, lots of them, and then 60 more? And
I mean, this is brilliant, isn't it? We've got this system now with 60 minutes in the hour, 12 hours in the half day, or 24 hours in the day, 60 seconds in the minute. And we think perhaps that there must be some really important technical reason why that is the way the world is.
Yeah.
And there isn't. And it could be literally anything. And one of the reasons I get really excited about the long history of timekeeping is that the reason we've got 60 minutes and 60 seconds and 24 hours goes back 3,500 years, goes back to the ancient Egyptians, the ancient Babylonians, who, for reasons which were important to them then, the numbers 12 and 60 were really important. In the case of why is it 12 hours and 24 hours, it's the Egyptians who, their astronomy, they'd have like 6 or 12 stars that would pass overhead at night, at roughly even intervals, which helped them divide their night up and then their day, so that they could make sense of their lives. And the 60, the Babylonians knew that 60 is a really good number arithmetically. It's a really good number for dividing the numbers up. So base 60 calculations they were really comfortable with. So when they started to develop the first water clocks and sundials, it made sense that they'd use the arithmetical system they knew. Now, when we talk about, well, why hasn't someone come along with a challenger system?
Why isn't there a decimal time system?
And the answer is, well, there's two answers to that. I mean, I really could go on for literally a decimal month about this. I mean, the point is that there was a decimal time system brought in the French Revolution in the 18th century.
Of course.
Part of their big project to decimalize and to metricate all measurement had to include bringing this last, most unruly of measurement systems, time, into some kind of modern rational order, rather than this irrational idea of ancient Egyptians looking up at the stars. So they introduced, a decimal calendar, so decimal months, 10 months in the year, which was all right. It meant that months were about 5 weeks long. And weeks were 10 days long, which didn't go down very well if you were waiting for the weekend. But they also brought in decimal time. So they divided each, what we call 24-hour period, into 10 hours. And each hour had 100 minutes, and each minute had 100 seconds. And makes sense in principle. In practice, there were something like 15 million watches in use in France at the time, in the late 18th century, 15 million watches out there. So either you have to build 15 million new watches, which tell decimal time, which is it's not technically that difficult for a normal simple watch. But if you've got a watch with a calendar or a repeating watch, a watch that strikes or sounds, really, really complex. So what are you going to do? Build 15 million new watches and sell them to people who don't want them, because the French people didn't want decimal time, or you try and convert 15 million watches to show decimal time, which is a massive technical job. And you'll not sell any of these watches outside the French market because it's only France that's got decimal time. So it was abandoned after about 18 months, 18 decimal months probably. But as you will know only too well, we've got decimal time now. It's sexagesimal from the second all the way up, 60 minutes, 60 seconds, 12, 24 hours. But anything smaller than a second, which is what matters to everybody who uses timing today, whether they're in industry, in science, sports people, whatever, it's tenths of a second, hundredths, thousandths, it's micro, milli, nanoseconds. That's all decimal. So rather than having this revolutionary diktat, which, like said from a point of principle, we should move to decimal time, which failed in the 18th century, we ended up with a perfect system that works for everyone and gives the specialists, the time specialists, all the precision they need and all the computational ease that decimal brings. And we never had to have that revolution. We just needed a need for it. And it just emerged. I
guess there might be another one coming. I was going to say soon, but in decades, in terms of leap seconds, all the hoo-ha that's going on whether to keep or to get rid of leap seconds. It's something they've effectively kicked into 20, 30 years time or something before they have to do anything. But I know there's a huge movement to get rid of them. And I'm going to be maybe controversial by just saying I think it's just poor software design. We have leap years, and sometimes February has 29 days. I know leap seconds, they're not as predictable. I know there's a formula that you can work out if a year is a leap year or not. And leap seconds are a little bit awkward but we built such complex system. Like if you think about GPS, we're flying atomic clocks in space, and the power level when it gets to the surface of the Earth is below the noise. You can't see it with a so there's all clever electronic signal processing, the physics, the taking account of relativity. The clocks are set slightly slower to take account of relativity, so all that. And then we can't handle the fact that some minutes have either 59 or 61 seconds in them, and we get at least 6 months notice. So it seems to me to be like, but then I'm not running a military operation or a commercial operation where they might be very severely impacted by leap seconds going wrong. I mean, we've seen, our support guys have seen what happens when leaps, and it's always every leap second something goes wrong somewhere. But I'll just fall back to that default position that it's poor software design or poor system design or something. But I know.
I've got pretty well developed views on the leap second. As far as I know, the decision's now being made that it is going to be abolished. As far as I know, the final kind of appeal court has judged that it will be abolished in, as you say, I guess 10, 15, 20 years time. And I don't run any of those systems either. But the system's been around since 1971. And it is very straightforward. You get your email 6 months in advance. You get your circular T, and it tells you you've got 6 months to prepare. And maybe there's been problems with implementing leap seconds that have never made it to the news for reasons of security. But if you discount that, then if you look at what actually has gone wrong when leap seconds have been implemented wrongly, we're talking about, a social media network going down for a few hours. You're talking about an airline booking system going down for a few hours. We're talking about things which are irritant, but can happen for lots of other reasons as well, and do happen. And I think, in my view, as a non-specialist, for humankind to decide that the way to deal with this, as I agree with you, this small irritant, which is well characterized, it's been well understood, and it's been around since the 1970s, that instead of just trying to work that out better, we'll just fall back on let's abolish it. And let's remember what that abolition means. Maybe this doesn't matter to most people, but I think it's important. For the first time in human recorded history, the time kept in civilian life, the time that we all keep on our clocks, will no longer have a connection with the rotating Earth.
Yeah.
The point of the leap second was to keep a connection between Earth rotation time, astronomical time, solar time, and atomic time, and it's only a fraction of a second. But I think when you do look back at the history of timekeeping, which has been until 1955 a history of Earth rotation, then to break that connection just seems a shame. Especially as you mentioned GPS. GPS doesn't use leap seconds. TAI doesn't use leap seconds. There are plenty of timescales available.
I was just going to say that.
Do not have
other timescales are available.
Other timescales are available. UTC is just one of them.
Yeah.
And anyway, I mean, whatever. I think the decision's made now, but I think it's a shame.
Controversial stuff. I did a search in my Google Photos for the word clocks and came up with some random photos, which I'd like to share with you. I know. There you go. Impressively titled. And I put them in a presentation. I said I wasn't going to do any slides, but then ended up doing slides. But they're just photos. So taking a leaf out of your book from the keynote. So this is the Seiko or Psycho, the punch card time clock thing that I saw in a skit. This was in the village near where I live. There's a baker's shop that has been there for decades, and it's closed down. It's being refurbished. And I saw this in the skit, but the skit was fenced off. Otherwise, I would have been in there. And had that out. I would have asked them first if I could take it, but it was all fenced off. And there was nobody around that I could ask. And the next time I went, it had gone. So I was looking, and this has got, I searched, I could work out the name of it from the photo, searched it up on the internet, and it's a clocking in and clocking out system built by Seiko. But it had like a nice retro vibe. I thought the hands on that clock reminded, my grandparents had a tease made when I was little, and it had a clock face that looked similar to that. So I'm guessing it's sort of 70s, 80s era tech. But it sort of chimed with me and took me back to some of the themes in your book of being controlled by clocks, or using clocks to prove that you were somewhere at some time, like clocking in and out. But I was going to get it out. I was going to put a Raspberry Pi in it, and I've got all sorts of plans for doing stuff with it, but it just didn't happen. I just missed that. So that was the one that got away.
Well, that's very sad. Lovely clocks. So that was a baker's shop, you say? So they must have had must have had a reasonable sized workforce doing shifts to make it worth having a system.
Unless the shop was used for something else as well, or whether it was I don't know. But yeah, it was like typical family run baker's shop in the local village. But yeah, sadly it got away. But so I was, as I said, going to put a Raspberry Pi in it, and this is some of the Raspberry Pi clocks that I've made over the years. And like you say, having a clock somewhere when we're sat at screens, even though it's on your computer somewhere, it's never big enough. I want something, that just sits there all the time and is a clock. So there's some that I've made out of Raspberry Pi. There's a Raspberry Pi one on the left with a little LCD screen, and on the right there's some little tiny embedded devices. I think I've got one of those still over here somewhere. This little fella. So this is just a little embedded microcontroller that you can program in Python. It's got sensors on it. This one's got a little plug-in thing that's a temperature and humidity thing. So it's just usually Internet of Things. People put these in buildings and use them as sensors to work out if people are present and not. And it connects to Wi-Fi, as everything does. This little one, you can synchronize it via NTP. So you push the button and hold it down, and it flashes up and synchronizes to NTP. But the three clocks on the right, getting the middle one synced was a nightmare because you couldn't do that without reprogramming it, and that's over USB. So you have to hit the program button, and then there's a delay whilst it downloads the code and then reboots and starts again. So I had to work out by trial and error to add an extra 4 and a bit seconds into the time when you actually program it. But yeah, wow. Some of the tiny little clocks that I've got in my office that I synchronize. This photo is some other stuff we do. Some of our business is selling these reference clocks that use PTP, the Precision Time Protocol. So this is a little bit like NTP, but it's got hardware time stamping, so the timestamps are a lot more accurate. But I thought this was interesting because there's been a huge debate recently over the naming of these clocks, which I'm sure you're aware of. So right at the bottom in the middle is a Raspberry Pi Compute Module 4, which is the master clock. So the original terminology that's baked into the standard is to use master for the reference clock and then slave for any clocks that are following that. And that's obviously very problematic language with the whole history of slavery, which I know you touch on in your book quite a lot. And so they've last couple of years come up with alternative names for those clocks. So now I think the preferred name is time transmitter for the reference clock and time receiver for the other one. But they went through, so this is the IEEE who own that standard. They went through several iterations of their sort of standardization process, and there was several suggestions on the list, and one of them was leader and follower, which doesn't work well for German speaking people as well. Leader is Führer, which has all sorts of negative connotations. But yeah, and so this photograph, all I was doing here, this is my home office. So this sorry, excuse me, if you ask my wife, this is our dining room. This is my lab. So that's our dining room table with a couple of Raspberry Pi. There's a little GPS receiver in the middle that's putting a 1 pulse per second signal into one of those, and then the oscilloscope is measuring the difference between the time transmitter and the time receiver. But yeah, I thought it was interesting how only relatively recently, when I first came across this debate, I mean, I studied physics and electronics at university, and in electronics, this concept of master and slave has been baked into the terminology for years and years. And I know there's all sorts of electromechanical clocks and electric clock systems that go back, and it was always the master clock, which is, problematic language.
I mean, this is a topic that I think I'm glad that these conversations are being had. It just helps us all think about history, actually. And actually, when you look at the earliest electromechanical clock systems in the 19th century, it actually wasn't originally master-slave, wasn't the primary language. Right. If you look at one of the first, which is the Royal Observatory's Charles Shepherd system, which was installed there in 1852. That's the big gate clock outside the gates of the Royal Observatory, the big white 24-hour dial that you can still see. And it's controlled by a pendulum clock, deep inside the observatory. The original wording for that was that the master clock was called the motor clock because it was a motor which was driving. Right. And that the clock at the gates was the sympathetic clock because it was operating in sympathy with the motor clock. Right. And in fact, if you look at the terminology of several of the early makers, it was only much later that the terminology, I mean, master is perhaps less problematic. Yeah. I mean, there's a gendered conversation to be had about master. But in the particular conversation that we're having here, then slave is the most problematic. So master has been used a lot more, but slave wasn't really the terminology for most early systems. And it was actually only when, now as far as I've been able to work out, it was actually a British astronomer working not at the Royal Observatory in Greenwich, but a British astronomer working in Africa, in South Africa at the Cape of Good Hope Observatory, run by the British at the time, an observatory which was partly built by enslaved people and used enslaved people on its staff because they were easier to work with, they said at the time. And when slavery was abolished, I don't want to get into it too much. I'd mention some of it in the book. But this guy came up with the idea of the slave clock. or rather the terminology. And I think it's very interesting that whether he was the very first, he was one of the first, that wording came up in either South Africa under slavery or recently post-slavery Africa is telling. And then, as you say, it then got baked into later horology and then into electronics and electrical engineering systems. Well, that's history, isn't it?
Yeah.
I mean, having that language used now has to be, in one sense, good because it helps us look at the uncomfortable past of all of our subjects.
Absolutely, yeah. But it's something we should be aware. You can't. Some of my colleagues and people I've spoken to have sort of dismissed it, and the whole idea that it's people say this, don't they? Political correctness gone wrong, which is just an excuse, I think, for not being sympathetic and not understanding, not being empathetic and understanding. You can't tell someone else how to be offended. You can't decide whether someone else is offended or not. It's that sort of discussion, I think, isn't it?
And it has to be good for all society for us to have these conversations.
Yeah,
it has to be good for all of us to be open and open to new ideas, new ways of considering things. I mean, we all benefit.
Yeah. So got a little bit deep there, away from the. I'll take it.
That's
back.
The thing with clocks. You can't fail to get into the deep subjects because it's all about the most important subjects of humankind. Oh, science. Yeah, I used to use it.
Yeah, so I was obsessed when the Scion Series 3 came out in 1991. I was obsessed with it. I was too young. You wouldn't believe it. I was too young to be in the Scion Organizer Brigade. So the earlier ones, the sort of the more yuppie, the little square form factor, like a programmable calculator thing. But the Scion Series 3, I was obsessed with it. And recently, again, I think it started in lockdown. There was Scion made a laptop in 1989. The MC400 that had a touchpad on it. It was battery. It would run for like 40 hours on AA batteries. It was multitasking, had a graphical GUI, all these things, but it just didn't sell because it had their proprietary software on it, and everybody at the time wanted DOS and Windows. And I think again, it was in the lockdown period where looking for things and bought one on eBay, so started collecting them again. And again, this is what came out. And on the right is one of their industrial handheld computers that they made around about the same time. And I'd just written this little program just to display the time. This came from originally, I had a Scion Series 3A when I was working. So I worked in Liverpool for a while on Edge Lane it was Plessey when I had the interview, but it was GEC Plessey by the time I started working there because they'd formed a joint venture. And later it became Marconi. And I was working in support, and we were working sort of shifts during like early or late shifts in the day. And I wrote this program to count down to when I could finish and go home. And then just tweaked it and managed to put it on all these. So yeah, that came up when I searched my Google Photos for clocks. But interestingly, that site on Edge Lane was an ATE site, which I know we're not supposed to be talking about traffic lights today, but I found as well, one of the other things I found during lockdown was I walked around the local area where I live more than I'd ever walked before because there was nothing else to do. And, we've got a dog and, we were out and about. And I discovered, this is really sad. This is really sort of telecom nerdery. Looking at the, I was going to say manhole covers, whatever they are, the duct, the lids that they put on top that have got either GPO telephones, post office telephones, BT, British Telecom. And I found an ATE one, which I thought was, part of the telecom thing, but apparently not. It was an ATE electric traffic light system that used to be. It's not there anymore. The junction where it is, but yeah, it was a slight divergence into traffic light chat there.
Well, listen, I mean, I'm amongst friends when I find that you go looking at the duct covers, as do I, because around where I am in London, you'll see GEC, you'll see Plessey, both of which were big in traffic control, and ATE one of the most important because they were in the world of network systems, so it didn't matter. if you'd invested in understanding and building networks, you needed to leverage the assets that you'd invested in. So a lot of them would be telecoms firms. They would also do traffic lights. They would also do fire alarm systems. They would also do, and in some cases, connect all these systems up together. There was one wonderful system. I can't remember which of the firms made it, but it was a citywide traffic signal network which connected in with the fire, police, and ambulance control network, as well as the traffic signals, and connected in with the telecoms network, which meant that, if a fire engine was routed to go from the fire station to wherever the fire was, they would get a clear green light run all the way, and that other traffic might be routed away from their area if they needed to clear an area. And that all of this was happening automatically. I mean, electronically, but also quite a lot of kind of electromechanical systems, and and all of the evidence of that is, or at least the trace evidence of that is in these duct covers, which never really get changed when you resurface the roads.
No, that's right.
You get a brand new road and it'll say Post Office Telegraphs, and it's from the days of before the telephones, and now it's got fiber optic running through it.
Yeah, I was in Cambridge the other week, walking down the street there, and saw one that said, what was it called? Energis. One that said Energis on it, which is very rare. But again, I mean, these companies get acquired by other telecom companies, and as you say, they don't go around changing all these covers just to put Vodafone or Cable and Wireless or whatever on them. But
so there was a network around London called the London Hydraulic Power Company. In the 19th century, it was built, and it was high pressure water mains. So that was before before electricity and electric motors that would operate everything, or internal combustion engines. So if you had dock gates and cranes at the docks, if you were running a theatre with curtains that needed to be raised and lowered, if you had elevators in tall buildings, we now think of all of those either as electric motors or as diesel engines, probably, or petrol engines. Well, they were usually run by high pressure water mains piped in from central stations, which would generate the pressure. There's this whole network around London of the LHP, and you can see their duct covers all around the streets to this day, where it was either a valve, control valve, or access to the network. Well, they went out of business actually quite late in the 1960s, and then it went into various ownerships. But Mercury Communications, when they turned up when would that have been, the 70s? Maybe the early 80s. They were looking to build fiber networks or cable networks around the city. Now, anyone who's involved in network infrastructure knows that one of the hardest things is getting the way leaves. It's getting the legal permission to run cables under private properties or under public streets. Well, imagine if you come along and there's this ready-made network of pipes about this big, cast iron, which you can drain of water, and they run across the entire London central area. They bought LHP so they could thread their fiber cables through.
Wow.
And to this day, you see an LHP box from the 19th century that used to run the dock gates or the elevators, and now it's got the very latest fiber, the fiber networks that are keeping the data centers connected and all of that. And that's what I mean about why infrastructure interests me, whether it's time infrastructure or whatever, is this is physical stuff that costs a lot of money to install and a lot of human labor to install. Doesn't just disappear when it's redundant. And so you can track back centuries, century and a half, maybe even starting to get to be 2 centuries, by looking at your feet as you walk around. Seriously.
Yeah, it's fascinating stuff. Let's see what else is on the clock. Oh yeah, this is a big part of our business now. Is because, as I'm sure everybody's aware, GNSS systems and GNSS time is used as a reference for most things, for everything really today. It's used for the power grid, it's used for the telecom networks, and you can't do a lot today without either telecom or power. And as I said earlier, the signal is fragile. It can be interfered with. It can be spoofed. But that doesn't mean it's all doom and gloom. All these networks are built with some degree of resilience. And we're going through, I think at the moment, the process of addressing, have we got enough resilience? Is there enough resilience already built in, or do we need to look to other radio signals? We're looking at other low frequency, high power radio signals, like some of the old navigation systems like LORAN and eLORAN. Or do we fall back to completely terrestrial based fiber, based to network connections? But then for things like the power industry, where they've got assets out in the middle of nowhere, they've got rural assets where there isn't fiber, what do you do? But this photograph that came up, this was I think it's a Black Hat conference or something, where software developers, hackers get together and try and break things. This was a guy I think he spoofed an MSF or spoofed maybe a DCF signal. These are two radio controlled clocks, and his demonstration was he made the clock. He made these two clocks the mirror image of one another, so the minute and the hour hands are at like 180 degrees, or he made one run backwards or something. It was some dramatic demonstration where he just basically used, as you can do, you can, for a few £100, you can get a Raspberry Pi, a software-defined radio. You can download some software from the internet, from GitHub. You can get tutorials on the internet. You search on YouTube, and you can literally copy and paste commands onto your computer, onto your Raspberry Pi, compile the code, and then you can generate a spoof GPS signal, or maybe an MSF or a DCF signal. And that's becoming, as I say, more and more a conversation we're having with our customers, particularly for critical national infrastructure, where obviously it is a significant, if the power grid goes down, if the telecom networks go down, if there's some attack on financial markets and the financial services industry, it can have serious consequences. So we're talking to our customers about ways to increase resilience, and maybe look at other systems or products that are being designed now. There's a thing called a GNSS firewall, which effectively sits between the antenna on the roof and your GPS receiver, and then it makes a decision for itself whether it thinks it's a spoofed signal or not. Because lots of the sort of Raspberry Pi, the simple based spoofers, leave lots of the data that's in that radio message from the satellites. They leave them at default values, or some of them don't make sense, and you can tell it's not. You can tell it's not a live sky signal. So it's putting, the Americans call it smarts, putting extra intelligence, putting a layer of extra intelligence between what might be a legacy already installed system. I mean, modern receivers are getting that sort of system built in. I know both Galileo and GPS are starting to put authentication in the signal itself. So that works like you have to wait for about 3 or 5 minutes until you've received a significant portion of the radio signal, and then you can check the authentication using standard encryption and cryptography techniques to then say, yes, we think this is a valid, so the system can then lock onto it. But it's interesting how, in terms of talking to customers and talking to people about it, there's this sort of conversation. They think it's electronic warfare, or they think everybody wants to think it's somebody else's problem. It's really a cybersecurity problem, and putting it in with, people think cybersecurity is all about making sure you've got a password that's easy, that's not easy to guess, and making sure network security, but it includes these other interfaces as well, because as we've already talked about, lots of infrastructure is built on the concept of a trusted source of time, and all the receivers that have been deployed, maybe going back 5 years prior to that, all the GNSS receivers that have been deployed are effectively dumb receivers, in that they'll look onto anything that looks in the slightest way like a GPS signal. So they trust it implicitly. So again, it's that, as we were talking about before, a trusted source of time. And it's just interesting how now it's starting to come into sort of day-to-day business in the cybersecurity world. People are starting to realize. And again, I think in critical infrastructure, there's been this split between IT and the OT, the operational technology, the sort of electronics that operates the valves in the water pumping station, or the relays that turn the high voltage transformers off if there's a fault. All that estate is seen as separate from IT. But in some cases, they're often mixed. There's a link because, we know that they've got an NTP server in the IT network. So we'll just take the time for our whole network from this one box somewhere that probably nobody's maintaining. So yeah, interesting stuff.
And my sense as a layperson, I mean, this is all fascinating, and I watch it with great interest. My sense as a layperson is part of the problem has been how clocks of whatever kind have just been hidden. It's that they're so embedded in systems at a very kind of low level or at a very deep level that it's hard for anybody to remember where they came from, where their time comes from, and what's connected to them. As you say, that the idea that everything defaults back to this one box that's been there for years, and nobody thinks about it because that's somebody else's department.
Yeah.
My sense is that it's that hiddenness, and therefore the fairly recent kind of open conversations about the vulnerabilities of GNSSs and of precise timing in general, again, is wonderful because it's just opening up that conversation so people think about their own circumstances, their own business or their own industry, and start asking questions which get good answers and get more resilient answers as a result.
Yeah, I think it's part of the open source software movement's argument for security is that everything's out in the open, so it can be inspected by anybody. So anybody can look at it, and everybody can try and spot weaknesses. And a similar thing goes back to I went to the Institute of Navigation conference in Fort Worth in Texas a long time ago when I just started working for Chronos, probably 2000, same year when I saw your presentation at ITSF, 2007. And they had a tutorial before the conference about GPS jamming or GPS interference, and it was in America. So there was some American military personnel there in full uniform, sat in the, it was a civilian conference. Obviously, the military guys go to it. And one of the tutorials was about GPS jamming and interference, and they talked about a nightmare scenario. They talked about building a GPS jammer into a Coke can size, into sort of half a litre size bottle, buying weather balloons off eBay, building 20 of these things and flying them on a sort of 10-kilometre grid over the eastern seaboard of the United States, and putting electronics in there so the jammer's not on all the time. It randomly turns on and turns off. So as far as you're concerned from the ground, there's interference that's, killing GPS, killing all the position and time on the ground, but you don't know where it's coming from. And the guy that was giving the lecture said, oh yeah, the weather balloons, they're a square meter, they're cold, it's really hard to shoot down with a missile. Whether that's true or not, I've got no idea. But the military personnel were very upset that this was in the public domain and it was being talked about. They were really getting, quite heated and quite angry. This is unpatriotic, and this is, you shouldn't be talking about this. But I think it absolutely needs to be talked about. Otherwise, how do we build systems that we can protect against that sort of attack? But it's that, I guess that's more of a military mindset, maybe. I don't know.
It certainly seems that all of this is a wonderful opportunity for engineers, as the threats change, we need engineering solutions.
Yeah.
You talked about that GNSS firewall between the antenna and the unit, and presumably that'll help solve the problem for a while, but then the bad guys will find a way around that. And, and so it goes on. You'll find a way around that, and they'll find a way around that. And, that's life, I guess. But,
it is that typical cybersecurity. Sorry.
Has there ever been a better time to be an engineer? Because the opportunities to solve real world problems that are hard but solvable. Yeah. Interesting stuff. Right. Let's see what the next photo. Okay. So this is clocks that I've visited. This is I'm not going to ask you to name them, but I don't know whether you recognize any of them.
On the left is in Dusseldorf. This is the Rhine Tower, and it's a really rubbish photograph because it has lights down the center of the column that are like digital representations of the time. So there's a number of blobs of hours, minutes, and seconds. I've actually got a video. So ITSF was in Dusseldorf the year before last, and we went to see this clock at midnight to watch it roll over from all lit up to all off, as you do if you're into that sort of thing. So I've got a video somewhere of that happening.
Nice.
The one in the middle is in Chester. When I was little, my mum and dad, they had this picture on the wall, and it always used to freak me out because it was a painting of this clock, but it had a clock movement in it. In the back, there was a little battery operated clock. I remember being really freaked out how it was a painting, but I knew it was a clock, but I didn't like it because it moved. I don't know. It was weird. And that's in Chester. And then the one on the right is in Prague. That's I think there's some sort of astronomical aspect to that clock.
Absolutely.
Yeah,
that's on the old town hall.
Yeah,
one of a suite of those really complex astronomical and astrological clocks from centuries past, usually in cathedrals like Strasbourg. But the Prague one is interesting for the fact it's on a secular building and it's on the outside of that building, so everyone walking past gets to see it. I mean, what are you looking at with those? I mean, you talked about being concerned about the painting that moved on the wall. With those astronomical clocks, you can just imagine, if you're in the sort of the 16th century or the 15th century in Prague or Strasbourg or wherever, what that clock was showing you was the very universe itself moving in real time. It was a facsimile replica of God's universe, moving at exactly the same pace that the universe. You can see the stars, the sun, the planets, the moon. You can see them moving in the sky, and you can see them moving on the clock as well. And the clock was made by humans, but it was a way for believers to see God's perfect universe here on earth, which just made them even more kind of pious and even more in awe at God and the people who ran the church. Imagine how it must have felt to look up, and you will have had to look up, of course, these things are huge.
Yeah.
This, and not feel really small and really humble in the universe, and therefore, I'll worship at your church.
It must have seemed like looking at the future. It must have been like highest tech, the things that we look at now that we can see over the horizon. To them, it must have looked like the same magic.
Without any doubt, yeah. The astronomical clocks were not just in Europe, but before that, there were astronomical clocks using different tech in the Islamic world, which were the most complex technology in existence, without any doubt. But actually, you just said there for a moment, it must have been like, look, I mean, I said it was like looking at God's universe. You said it was like looking at the future, and it absolutely was. I mentioned astrology as well as astronomy. And if in Europe, in the 16th, 15th century, everyone believed in God, well, everyone also believed that the patterns of the movement of the stars and the planets dictated the course of our lives here on Earth and allowed us to predict the course of our lives. And that's what astrology was. Mm-hmm. So if you wanted to predict the best time to sow a crop or to harvest a crop or to understand what the weather's going to be doing or the most auspicious time to get married, people believed that the movement of the heavens influenced and our existence on Earth. And it's easy to mock that, but it's ridiculous to mock that because action at a distance we live with all the time. What is gravity but the heavenly bodies affecting the course of our lives here on Earth? So people believed it really strongly that these clocks were predictions of the future and that those astronomical clocks were the most awe-inspiring predictions of the future. Imagine how, like I say, how would it have felt that what I'm looking at is God's universe and the future?
Yeah, mind-blowing.
And they're still there, many of them, that one is.
And my little embedded controller clock, the battery's gone flat in it, so that tells you that's a comment on the scale between the two. Right, let's see what's next. Oh yeah, on the left, Vancouver, the steam clock, which I was there last March, I think it was, March last year, and plays a little tune, does all sorts of tricks, but it was cold, it was very cold, so there was lots of condensation inside the clock case, so it was dripping inside with water. And then the next day, these guys turned up, and I don't know what they were doing, whether it gets a regular clean or they changed the oil in it or something. But I think that was, is it in the part of Vancouver called Gastown, I think, which it was gifted to the city by someone a long time ago. But I guess you know a lot more about that clock than I do, maybe.
Well, I've not seen that actual clock, but the idea of utility companies gifting public infrastructure like clocks. I mean, when we look at public clocks now that are backlit, the dials are backlit and don't give it a second thought. But when they were first invented, they were lit by gas lighting, and often it would be maybe the gas company wasn't actually gifting the clock to the town, but they would gift the gas to keep it lit.
Right.
Because everyone looks at the clock. It's this symbol of, civic pride, as we can see in that picture. It's something that's still maintained, even when it needs just a good mop out. And there's money behind that as well. People knew that if you want to leave a legacy, give a clock.
Yeah, indeed.
I'm intrigued to know which is the one on the right.
Right.
Is that in Canada?
Yes, that's in Ottawa.
Okay.
And I think that building is like a mini Houses of Parliament, mini sort of Westminster with a mini sort of Big Ben-ish thing on it.
Indeed.
So I know you mentioned Big Ben in your book as a symbol of Britishness and the whole hoo-ha around getting it to chime when the UK left the European Union. But this is in the old empire, the old in the just about Commonwealth, I think. But yeah, I was interested when I was there how it looked like it had been built in the style of London.
I mean, the British Empire, not just the British Empire, but it was one of the biggest. They built clocks, tower clocks like Big Ben around their empire. I mean, I talk in the book quite a lot about the big public clocks across India built from the 1860s onwards by the British, many of which resembled Big Ben or clocks like it. But also, in Australia, we built clocks. In Canada, we built clocks. Wherever we went. I mean, I was in Malaysia a little while ago for a conference, and the public clock from the 19th century is a British clock. The mechanism was made in Croydon in South London, still working and still maintained by Malaysia itself, because it's kind of a symbol of defiance, I guess.
Yeah.
In that they got their independence. And now the clock looks over a public square called Independence Square. I got interested in a clock which I'll never be able to see. Perhaps you might not be able to see. I don't know. Which is in Mecca, in Saudi Arabia, at the very heart of Mecca, and a huge clock tower that overlooks the Great Mosque at Mecca, the most holy site in Islam, and non-Muslims aren't allowed to visit Mecca. So that's why I wasn't able to visit when I was out there. And it looks like Big Ben, but it's an Islamic version of Big Ben. And it seems to me a consciously Islamic version of Big Ben, but it's 6 times the size of Big Ben. It's one of the biggest clocks in the world. It's a third of a mile high. The dials of Big Ben are 7 meters in diameter. The dials of this clock are 43 meters in diameter. And at the time that it was built, about 10, 15 years ago, overlooking the most holy site of Islam, looking like 6 times the size of Big Ben, And at the time, some Saudi officials were lobbying hard for the prime meridian of the world to be moved from Greenwich to run through Mecca,
Right.
Because there's politics to all of this as well. I'm sorry for keep banging on about the politics of it, but that's what fascinates me. About what clocks look like and where they are and what time zone you're in and where the prime meridian runs through. Well, it's politics as much as it's technology.
Yeah.
Which is why I'm fascinated so much by it, I guess.
Yeah, I mean, we still say Greenwich Mean Time when we say GMT. It's still Greenwich. People still say the word Greenwich, don't they? Now, because
absolutely.
Because of the meeting they had, and they came to the decision to run that prime meridian through it. So I think, this is the countdown. This is the Die Hard, the Christmas Advent calendar, the countdown. Hans Gruber falling off the top of the Nakatomi Tower. This is a Die Hard fans Advent calendar, I think, which is a sort of clock, which for some reason came up in Google Photos when I searched for the clock. And one thing, so I think that's the end of those slides. One thing I didn't find, I was looking for a picture of the Liver building in Liverpool. So I live in the northwest of England, about 20 miles north of Liverpool. And a few years ago, I had a visitor from the States, and we were looking for something to do. And I took him on the ferry. They do like a tourist ferry across the Mersey, and it takes you all over. And apart from the Liver building having a big clock face on it, which apparently the directors of the company had dinner. They used it as a table and had dinner around it before the first one was erected. Further up the coast, only a couple of miles, there's another dock with a 6-sided clock tower. And this little narrated guide on the ferry says it was because they thought from a 4-sided tower, there are certain angles where you won't be able to see the clock clearly enough. So they built a 6-sided, and it's still there. The rest of the dock is looking in a bit of a state of disrepair. But it's the first time I've ever seen that 6-sided clock tower in Liverpool. So I was looking for a photograph of that, but then forgot to put it in. But
I mean, I should get to see that. But I mean, clocks and docks. I mean, if you're interested in why the world is the shape it is and how empires got built and fell, it's to do with ships, and it's to do with navigation and longitude and setting your chronometer right before you left whatever dock you've put into to a fraction of a second was the difference between life and death. I mean, if your chronometer was wrong by 2.5 seconds, that's like, if I remember correctly, that's like half a mile to a mile of navigation error, which might make a difference if you're approaching the shore. Yeah. So, when I get fascinated, I mean, I like chronometers, I used to work at the Royal Observatory. You've got to be interested in marine chronometers, but the infrastructure of clocks and time signals and time balls and time guns and time flags around the coastlines of the world, including that 6-sided clock, which I must get to see, it's testament to how valuable time's always been. And how, this conversation, which I'm really enjoying, just reminds us just how valuable time is in all aspects of our lives, besides knowing what o'clock it is, that it enables so much of the modern world to work. All of the modern world relies on precision time, and that it's the clocks that your companies like yours make, and the distribution networks and the maintenance of all of these that it makes the modern world what it is. And I love that.
Yeah. I was up, so, the MSF signal we mentioned before, it used to be rugby. Everyone used to call it a rugby clock, and then it moved to Anthorn. So there's an Elan transmitter up at Anthorn, and we've got some prototype Elan timing receivers that we've been testing. And part of the testing involved taking them as close as we could possibly get to that transmitter, which meant going just into Scotland and coming along the coast. So there was about 20 kilometers distance over seawater, because Elan, the signal and the way the time is derived from the radio signal, it is the best case is if it's transmitted over seawater. So we're trying to get as much of the estuary in the path as possible. And I was actually up there testing, because then we know that it's effectively zero additional secondary factor. So there's a physical speed of light delay, and then because that wave travels as a ground wave, there's some that gets reflected off the sky, and there's all sorts, call it ASF, additional secondary factors. And to get in the near far field, as they call it, which was about 10 wavelengths away. So I was there testing these receivers and trying to calibrate them. And there was an issue with the timing for that transmitter, and I was lucky that I had the right clearance. I could call in on the way back and actually go on that site and see the transmitter. But it was a beautiful, bright, sunny day, but it was freezing. The wind, because it's right on the coast, that northern, northwest coast just before Scotland, it was absolutely freezing. But yeah, it was interesting. Again, another coastal installation, I think, because again, this transmitter, E-Loran, was designed. Most of the transmitters that were in the chain when they were used for marine navigation were coastal installations as well. So,
and I mean, there's good reasons why Anthorn is there, and the things that Anthorn does is pretty significant for the world. I mean, it makes sense, therefore, that MSF moved there when it was recontracted out. Very strategic part of the world.
Yeah.
And I'm deeply envious that you managed to get in and have a look.
It's just racks of electronics,
Yeah,
one thing.
What beautiful racks of electronics.
Yeah, but there are certain racks of electronics that you get to go into. I remember in my previous job, when I started working support in the late 80s, in the 90s, when I was supporting BT's network, I got to go into Baynard House in London, and that was where the whole PSTN, public switch telephone network, was synchronized from. There were 3 cesium beam tube clocks that were in a System X exchange that were in there, and I ended up, through a random sequence of events, actually supporting that infrastructure for BT. So I've got to go in there and have a look at that. But yeah, fascinating stuff. So are you working on anything at the moment? Have you got another book in the pipeline? Is there anything?
I'm moving from clocks to something else, which doesn't seem to have any connection with clocks. Perhaps it doesn't, but I'm interested in the history of technology and the history of engineering more generally, and also in kind of transport. And I'm writing a book about the first ever aeroplane flight across the Atlantic Ocean, which took place in 1919 in a fabric biplane with an open cockpit and 2 seats, and 2 guys from Manchester flew it from Newfoundland to the west coast of Ireland in 1919.
Wow.
The first flight across the Atlantic. It's a story that's not so well known, really. The aeroplane is in the Science Museum where I used to work.
Yeah.
And an amazing thing it is. But the story of that flight and what went on around it is, I mean, the word epic gets overused, but it is a true epic. So I've been working on that for a couple of years, and it's been hugely interesting. But I'm interested. I keep a few irons in the fire, so there's other things going on in the horology world as well. It keeps me busy anyway.
Jolly good. Well, it's been really absolutely fascinating talking to you. Thanks for sparing the time to listen to me waffle on about clocks I made in my dining room.
It's been an absolute pleasure talking, because I mean, I think we're both interested in the same thing, and I think more dining rooms should be like that. Without doubt.
Save that clip and show it to my wife when when we have the argument about there's a family birthday or some Easter or Christmas coming up, and then we have to use the dining room table for dining, which is just wrong to me.
Well, I suppose once in a while.
Okay, well, thank you very much, David. It's really
thank you, Chris. Great pleasure.
And look forward to talking to you again in the future at some point.